Good morning, fellow Pythonistas. Welcome to today's coding video. What I just want to do today is a little bit of a recap from our last video. There are a couple of things I didn't show, and I was worried that that video was going to be so long. 51 minutes was quite long for most of the videos we tend to put out in this channel. But I thought I could just do a short video. I don't know how short this is going to be, but I will just try and show a little things and do a little bit of a recap and then add one or two codes I feel you might be interested in, seeing. Without much ado, let's hop into our Colab. I've already prepared some of the data that I'm going to be sharing with you. As you can see here, presented to you is one of the data sets I curated for my last video, which I'm sure you should have watched. If you haven't watched it, somewhere in the description, I'm going to put a link to that last video so that you can watch it. That is the longest video on this channel to date. I probably will do it longer next time. I'm not sure, but I just want to keep it, to the limit that most people would accept and tolerate. So this is a data set I've curated for, I think it has to do with the 10 highest paid football players. Some people call it soccer, but we here in Europe, Africa, and Asia, we call it football. And this is a code for it. Video, I shared the code in the last video and the notebook too. So if you're not even a member of my Python with Friends Google Classroom, I will also drop the link to join in the description below so that you can join and have access to the notebook. But here I will just stop a bit for you to view it. You don't have to make your data set exactly like mine is, just to get along. But if you're really interested, check the description below for the last video, and then even for the Google Classroom so they can go have access to all the data sets. So this is the code that will transform that dictionary into a data frame. All right. This is our pandas, the alias we gave the pandas alias. Then this is a code we have to run. This is a function that accepts a dictionary or whatever format you have. This is for a dictionary. This is a dictionary we created here. And what I want to do, there's a column in that dictionary that's called name. I want that to be my index. I believe I've explained everything in the last video, so this will not be too strange if you've watched it. And if you know anything about pandas, this is not a big deal. So when we were creating this data set, we give them, for this video, I decided to call it data 1 because I have several others I want to share with you. All right. What I'm going to do now is to run this first cell here, which is to import pandas, and I will call it PD. We know all this. This is not strange. Like I said, it's just a recap. In case you're going to create your own data set, some things you have to put in mind is the fact that the values of the data set across board must be the same. I have 10 names here. If I have 10 names for the values, remember how it is, key value pair. If I have 10 names, I have one key name, and the values should all be in a list containing 10 names. The key here is age, and I am giving it a list as a value, which should also have 10 integers. And we have total earnings here as a key, and the value contained in the list should be 10. Same for the endorsements. Why? Because they have to be the same. If they're not the same, Pandas is going to complain and say, yeah, but they're not the same. You didn't give me the same values. So what do I put in there? Except you can find a way of telling Pandas, okay, make it not a number or something. But for now, to make it simple, make sure the values attached to each key are the same across board. So for name, the value attached to name must have 10 values. Same thing with age, total earnings, endorsement, salary, team. If I had selected only 7 names, then everything across board must be 7, right? So here we are. Now I want to introduce you to something called chaining. It's a way of making your Pandas code readable and very easy to edit. You can see here I have brackets here to chain the whole code. Then I broke the codes into readable formats like this. So no matter how long the codes are, I'll just arrange them line by line. There's several reasons for this, which I'm going to show you now. One of them is I could just comment out a line and then run it and see what happens. We know what this is. This will give me a sample of 3. I could make it 5. If I should run this, what you would notice here is that in this data frame, the name is a column. This is a sample. It just gave me a sample of different values, right? And I could use the tail function. Let's see what that gives me. Tail. Right? So what we can see here is the fact that the name here is a column on its own. So if we do something like, df1.shape, we're going to see that we have 10 entries. Of course, we know it's 10, and 7 columns, 1, 2, 3, 4, 5, 6, 7. So I'm going to uncomment this line now. I'll remove the hash tag and then run it. This will set that column name as my index. So the names here, I can also hash this one out so it prints everything. So the names here are like index labels now. I've labeled the indexes with the names of the players. However, Pandas is seeing those index names, the values Pandas has assigned, it also can read it. So if I want to access each line, each entry, based on the label names, all I need to do is to use the name of the players I want to use to see. Let's assume I want to see Gareth Bale. I use the LOC function, if you remember from the last video, and put the name Gareth Bale here. That's going to give me everything about Gareth Bale. All of this will come out. If I chose like a couple of names, but if I want to access it via the index, I have to use ILOC. Then I will get all the details that is contained in those entries based on the index number that you can see. Normally, I will use iLook if I want to access the last value and I don't know what is there. But let's not get ahead of ourselves. We've done this in the last video. Like I said, this is just a form of a recap. I'll just run this line so that you can see that it becomes 10.6. It's not 10.7 anymore because I've converted one of the columns to the index. Same here. This data set here was given to me by a good friend of mine, Liberty. He is also in the group. He curated this data from somewhere. And the same thing. If I could comment this out and then run it, this is a sample as usual. So we want this date here to be our index. That's the reason for this line of code here. So I can uncomment that and rerun it again. We can see that the date column now has been shifted and made the index. So the label for that index is the date here. So we're going to enter it as a string in double quotation marks or single quotation marks, depending on you. And then here, I'm going to take a data set from, I have it on my desktop. So I'm going to take it from the desktop, and we all know how to do that. Like I said, this video is a sort of a recap. So I'm going to click this side. If you watched my previous videos, you should know how to do this. And first thing I need to do is to mount my drive, give it permission. Very soon you'll see it appear somewhere here. There are only 2 folders here. You should see a third one appear in the middle. Voila. I'm sure you can all see it. The drive just appeared. All right. So what I can do is I can choose a folder within. This folder is in your Google Drive. That is why I decided to use Google as an ecosystem for us to learn Python, because everything is contained within the Google Drive. I want to upload it here. I think I have the file in my download folder. So I'll just click here, upload. I should see where my file is. It's download. That's good. I just move there, and this is Gapminder. And I'll wait for it to upload. So I'll just go back right where I think I dropped it. Here it is. And I will copy the link, copy path. Copy path. I'm going to change this just in case it's not correct. I know it's the same. And then I just drop this. This is where it is. So I don't need to see that place anymore. I can now just move ahead and run this as path. You can call it whatever you want. It's just a variable name, like I always say. So we have df1 here, we have df2, and I'm now going to make this one df3. It's just for it to be sequential. You can choose whatever you want. But one thing we have to note is that this is not a CSV file. It's not an Excel file. It is not a TXT file. This is a TSV. TSV means tab separated values. CSV means comma separated values. The good thing is I think you can open both with Excel. I haven't really opened it. But one thing I'm sure of is the TSV file you can open with your notepad if you're using Windows. So how do we get it? We have to add here, sep. So you use a backslash, then you put in the T. That is how to get it running. So I've run here, you can see it has clicked good here. Then I run this one and I print a sample. This is a sample of what the data set has. Now, sometimes you might not have this data set on your system. you could just do a Google search. Like the name here is gapminder.tsv. I could just open a new one, a new site here, and just a new tab, and just go gapminder.tsv. I've done this search before. And I can select any of this. And you can see somebody here has the data set on her GitHub. This happens to be a lady. I originally got it from a guy called Daniel Chen. He has a very good session on how to play around with pandas data frames. You can go check it out if you're interested, if you're so inclined. And this is the part I am interested in. Click on raw, then I copy it. If you're getting this from a GitHub page. So I click, and you can see it has changed. So the part I'm now interested in is here. Just change the color so that it doesn't clash. Right? Alrighty. So I'm gonna copy everything here and come here and just change this because they're not the same anymore. But and let's see what I get. So I run this, check mark here, it has been run, and then I print. Yep, the data was gotten all right. I could compare with mine. I could do, so the reason why I'm using DF3 here, DF3 is because it's supposed to be the same data. I'm just showing you different ways of doing it. So I don't want to have too much in my memory. So I just have the same DF3, even though this is the one that has been run presently. And you can see it's also a TSV file. So I have to use the same thing now. Oh, sorry, there's a mistake here. I need to use URL here because this path here is a URL. I was busy running the same thing. So let's make sure your codes are running correctly. Yep, here it is. I mean, it's the same data set. You can see there's really not much difference. I could just change this and make it head and then run it. And also change this and make it head and run it, the first 3 entries. I mean, we can see that they're the same, I hope. I'm sure they're the same anyway. It couldn't be different because they all got it from the same source. So now we want to play around with our data set like we've done. Like I said, this is just a recap. I'll quickly just rush through this and just edit and submit it. This is the whole data for DF1, which is the first 10 football players, richest football players in the world. This is our index. And we have to subset from the names of the players now, the index labels. Each row has a different label based on the name. And the good thing is we are not repeating any name. If we were, then it would be useless to subset it this way. So we are not repeating any name. So each label is unique because each index position is unique. So if you're going to use the names, the labels as a way of subsetting, you need to make sure that they're not the same because it's like an address. If there are 2 number 20s of the same street, then when a letter comes, how does a mailman know which house this letter belongs to? It's just a lot easier to make sure every number on the street is unique. If there has to be double numbers to make one 20A and one 20B. If the guy sending the letter makes a mistake and forgets to put A or B, then that's where the confusion lies, right? But in pandas, if you want to subset, make sure that the label names you're using on the index are unique. If not, you just have to make do with working with the index, which is the ILOC. So normally, like I said, I always do this just to see the names of my labels of my index. I do this, and I want to select who do I play around with. Robert Lewandowski, Warren Mercy, Garrett Bale. I want to subset using their names. I want to see all their data. And that is why when we run this, we'll see we can change the name. I kind of like Cristiano Ronaldo. I'm not so much of a football fan, but I have an eye for Man U. And since he happens to be there, so just doesn't mean anything, doesn't change a thing. Are we on the right track? Why are there different colors? Cristiano Ronaldo, good. This is a problem. There's a missing quotation mark here. So I run this, and we can see Cristiano Ronaldo. So again, we let's try DF3, the data set we got from the Gapminder. We see the head. We've done that before. We've seen everything. It's a lot of data. If I take off the head now, you're going to see that it's very long. 1,700 rows at least. 6 columns. Yep, 6 columns. So here, what I wanted to note is that the index here has no labels. So we are using the index position as the labels. That is what pandas would do. So this is actually the most important part I want to present to you. Now, because we didn't move, let's say, country and made it the index, we don't have labels. So the index position, the numbers the pandas already uses to subset, to access the data points, is what is used as a label. So you have to know that when you're using the LOC or ILOC, it wouldn't be wise for us to use the country anyway, because you can see Afghanistan alone has several entries. Zimbabwe has several entries. So the index labels will not be unique, except you find a way of manipulating to make it unique, which is different. Even the year here is not that unique, because there will be 7 1952s. So when we're going to subset by label names, we can still use the numbers. But if we use ILOC, index location, we can also use the numbers, because the label names and the index locations are the same. So here we're trying to just subset a few of them. And of course, here we want to see the last 11, which is the same as the tail of 11. So let's see DF2. Let's run it and see what we have there. Okay. See a lot of numbers here. We don't know what they mean. I mean, we just added a lot of things to it. And this is made up data, as it were. The data are made up and so on and so forth. Looks like some kind of transaction. This is amount. This is money. I hope this is in dollars. Huh? All right. We want to subset this also. And we have labels. And as I'm trying to look at it, I can see that the labels are all unique. The index labels are unique. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 entries too. That's good. Let's see. Entries. Let me get rid of this guy. So let's do some subsets. DF2 dot log. Let's say, let's do it this way. I want to see the index names. I like doing that. DF2 dot index, just so that I can have them close to me and I can cut and paste. So you can see they're in quotation marks. That means they are strings. So I just want to see one. There you are. And then if I want to see another one, let me convert this to 10. But I have to remember that once it's a list, I need to convert it to double square brackets. And then I run that. So I'm looking at the first one and the last one. You can see it's working. But if I want to subset based on the index location now, it's going to be df2, there's going to be iLook, then 1 and -1, because I'm checking the first and the last. So the last is always -1. If I run it, you can see that this is the first, right? And this is the second. How about that? Should I throw in something? I mean, the video isn't too long, is it? I'm just throwing something. So I call it a recap, but it's not really a recap. I'm adding 1 or 2 things to it, which I'll come to later because we're not done with these data sets. I want to play with the one I created, and I want to play with this Gapminder one I just brought out to you. So let me play with the Gapminder data set. Let's see what I can do with it. So let's call it out. DF3 is the Gapminder data set. And we can see how long it is. What if we wanted to see Nigeria? So what do? We say DF3, then we open bracket and we call the name of a column. The name of the column is country. So once DF3 is equivalent to their strings, so I have to put this Nigeria. What do we get? Okay, we get this, whatever this is telling us, hey, false, 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 false. What does that mean? It means if the country label here is Nigeria, it will give it true, but we can't see because it's Nigeria somewhere down there. But I want to assume that there's Nigeria. So what do? I cover everything here with another square bracket and go out here and put another DF3. So what that means is that it is going to go through the whole data set and select just the one that Nigeria is true. Then it will publish it for us, print it for us. Voila. Can you see that? Simple way to play around with it, right? So everything here, this is everything about Nigeria. Remember that the strings are case sensitive. So if there's a Nigeria on this list that is with small n, starts with small n, it will not show here because it matches them exactly. So even if you're building your data set from scratch, you have to be very, very careful how you do that, how you do so that you don't mix. If anything is missing here, like, there's a slang in Nigeria, we call Nigeria Niger. Assuming some people collect data and they put Niger instead of Nigeria. And if I'm subsetting this way, I would not see that one because if I'm not Nigerian, even if I was Nigerian, I am Nigerian, it wouldn't cross my mind that somebody will go for an official function and then copy data and put Niger instead of Nigeria, right? So if there's Niger there, it won't appear. All right. So we're going to play with this data set much later, but maybe we can just do another one. So here I'm going to say DF3 again, and I'm going to open bracket, and I'm going to put Ethiopia. No, sorry, that's not. This is supposed to be country. Because those that is where we put the column name, and there's a column name here called country. So I'll say country, and I'm trying to say that the value in that country should be Ethiopia. If I make any mistakes in my spellings, nothing will happen. So when you just run it, it just tells you, okay, the one on index 0 is not Ethiopia, so it's false, 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 false. We can't see where Ethiopia is true because it is squeezed. Pandas has a way of showing you just a few of the data. You can put a function there to make sure it shows you everything, then the whole screen will be filled, and that could be overwhelming. So that's why we subset. So you put that, and then you put df3 outside. What it means is that go in the data set, look for the country column. Whenever the value is Ethiopia, show it to me. That is why we put the square bracket outside that, and then we add the df3 because we're dealing with the data set that we stored in the variable df3. And we can run this again. And we can see everything about Ethiopia here that's on that data set has been displayed for us here to see. I'll just do one more. I'm not stress you. What I want to do is I will use country again. You can try another heading. You can try another year. Yeah, I think we'll do that. I just want to show you the one for Zimbabwe because Zimbabwe is the last one. Zimbabwe, right? And when you're doing this, don't forget a double equal sign. And you can see the last parts here. You can see that is Zimbabwe. They're all true here. The last few ones. So the country column is Zimbabwe. So what we're trying to say now is in the whole data set DF3, anywhere that says Zimbabwe is true, display it for me. All right. We'll play with this Gapminder data set much later. We'll do a video on it. I didn't intend to make this one longer than this. I especially wanted to explain the index labels when we have labels that or the data set that was given to us was assigned labels, and then when we don't. For this Gapminder data set, the labels are the index positions. That is what was used as a label. Sometimes we import data and there's no index, so pandas would assign them. So you understand when you're using iLook and look, LOC, ILOC. If they are label names, you use LOC. If you don't have label names, then what pandas displays for you can be used as label names, and also you can use iLook with the same number, the positioning. Remember, the very last one is what? Is -1. Whether you have 1 million entries in your data set or you have 1 billion entries in your data set, the last one, as long as pandas can manage it, is going to be -1. And you can go back in minus like that. So the first one is, of course, always 0. We know that, but the last one is always -1. The one before the last will be -2. The one before the last will be -3. That is all I have for you today. I hope you like this video. If you enjoyed it, give it a thumbs up. And you can also subscribe so that you can get more videos. And if you want to join the classroom to see everything we've been talking about and how we've been doing it, there will be a link in the description below. Have a good one. Ciao.